write a code fragment which pulls 40 16-bit values of the stack. A part is asking with the pull instruction, and the B part is asking without using the pull instruction, and the C part is asking which algorithm is faster. So here what we have to do is we have to pull 40 16-bit values of the stack. First one using pull instruction, without using the pull instruction. The third one is faster. Let's do the A part. The A part, with using pull instruction, we have to pull 40 16-bit values of the stack. Now there's one way we can do this is by running a loop 40 times, and each time it pulls a 16-bit value. So it happens 40 times, it's gonna pull 40 16-bit values. To do that, we can load an accumulator A with a number of 40. LDA, we load the decimal number 40, and then we create a loop, and in this loop we pull X register has 16-bit values. X register is 16. So we do that, and then we do the decrement by A. Okay, and then we create a loop by putting a BNE, that is branch not equal to 0 loop. So this loop is gonna run 40 times because that is the number we set here. And why it's 40 times? Because each time it's decrementing by 1, and it has to be decremented 40 times to reach 0, because this loop only exits when this is equal to 0. This is branch not equal to 0, branch if not equal to 0. So it's going to keep on branching until it becomes 0. So it's going to happen 40 times. Each time it happens, it's going to pull X. That's a 16-bit value. So it's going to happen 40 times. So it pulls 40 16-bit values. And without using pull instruction also we can do that. We can do that by using stack pointer. So how do we do that? Like, first what we do is we transfer the stack pointer to X, ESX, and stack pointer initially you're gonna have SP, that is stack pointer, at this location 0 0 0 1. Okay, we transfer that one to the X, then we switch the X with accumulator D, DX. This one switch the X with accumulator D, and once it switch, what we do is now we add 40 to the accumulator D. Okay, so first we have transfer the stack pointer to the X, and we are switching the X to the D. Now stack pointer will go to the D. Now we are adding 40 to it. So now stack pointer is added with 40. Now we are switching back stack pointer to the D. So XGDX. Now whatever the store value in the D is going to be switched with X. So now whatever the stack pointer is going to be at X right now. And then what we do right now is we are going to transfer whatever the X value to the stack pointer. So when we do that, what will happen is the stack pointer will go to the bottom of the stack, bottom of the stack, by pulling all the above registers. So all the above mean like we put it to 40. Now all the 40 is going to get pulled. That is what we want to happen. We want to pull 40 16-bit values of the stack. So by doing that, it's going to pull 40 16-bit values. Stack by sum of the stack by pulling of all above registers. Above register. Okay, and the next part is asking which one is faster. The stack pointer method. Now this one is faster than this. We can mention second one is, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel.